Today we will be looking at target 6 and 7. Target 6 is all about determining if a point is a solution to a system of inequalities. Remember, when we talk about solutions, it has to make something true. If we look at A here, you're going to know we have two inequalities, and then we're also given a point. In order to know if it is true, you need to plug that point into both inequalities and make sure if they are true. If one of them is not true, then your answer is always no to the system. If both of them are true, then your answer is yes. Remember, our coordinate point always goes x comma y. So I'm going to plug 2 in for x and 0 in for y. So 0 is less than negative 2 times 2 minus 4. Negative 2 times 2 is negative 4. So 0 is less than negative 4 minus 4. And 0 is less than negative 8. That is not a true statement, so we know this cannot be a solution to this system. If that was a true statement, I would plug the point 2, 0 into that second inequality. If we look at B then, again, I have 5 for my x, and I have 0 for my y. So I'm going to plug 5 in for x in the first one, so 3 times 5 plus 5 times 0 is greater than negative 30. 3 times 5 is 15. 5 times 0 is 0, so I'm left with 15 is greater than negative 30. That is true. I don't know my answer is yes yet because I need to make sure it works for the other inequality. So I'll plug 5, 0 into x minus y is greater than or equal to negative 2. So 5 minus 0 is greater than or equal to negative 2. 5 is greater than or equal to negative 2 is again a true statement, so my answer is yes. Down here you're going to see a bunch of graphs that have shading on them. Right? To determine if a coordinate is a solution to a system of linear inequalities given a graph, we determine if the point lies within the double shaded area. So anything in the area up here where it's just shaded in red is not a solution. Similarly, if it is in the area that is just shaded by blue, it is not a solution. In order to be a solution, it has to be in the area that is shaded by both our red and our blue lines. Okay. The other thing you have to watch out for is a solid line versus a dashed line. If it ever lands on a dashed line, it is not a solution. If it lands on a solid line that is also shaded by the other line, then it is a solution. The point we are given here is 2, 2. If I graph 2, 2, going over 2 and up 2, that point lands in my solution area, in the area that is shaded by both equations. So yes, it is a solution. B, I'm going to graph negative 2, negative 2. So negative 2, negative 2, again, lands in the area that is shaded by both my red and my blue line. So yes, negative 2, negative 2 is a solution. Looking at C, I have the point negative 6, negative 4. So left 6 for the negative 6, down 4 for the negative 4. You'll notice that point is in the shaded area, but it is only shaded by blue. Therefore, it is not a solution because it is not a solution to that red line. It is not in an area shaded by both the blue and the red. And on D, we have the point negative 4, 0. Negative 4, 0 is shaded by the red line, but it is on the dashed blue line. If you are on a dashed line, you cannot be a solution. So our answer here is no. So again, target 6, we're just testing solutions either by plugging them into the system of inequalities or looking if they are in the area shaded by both graphs. Target 7, we are going to go back to our graphing. So we're going to graph the system of inequalities. Earlier this semester, we did graph an inequality. Now we're just going to have 2 graphs instead of 1. Sometimes it can help you if you struggle with this to use different colors, one for each graph so you can tell them apart. So my first inequality up here, I have y is less than negative 5x plus 2. That is in my slope-intercept form. So my slope here, or my m value, is -5. My y-intercept, or my b value, is 2. Just like when I graph a line then, I'm going to start with my y-intercept at 2, and then I'm going to count my slope of -5. Remember, that's always 1. So we can either choose to go up 5 and left 1, or we can go down 5 and right 1. When I connect these points to make my line, I'm going to connect them again with that dashed line. Remember, if it's not equal to, then we should have a dashed line. So I'll have a dashed line connecting all of my points. And then just as we did with inequalities earlier in the year, we need to remember to shade. You can shade either by picking your test point or looking at that inequality sign. So that inequality sign in my original equation says y is less than. So I want to shade everywhere on this graph where my y values are less than that equation, which for us is going to be on the left-hand side. That's my first one. My second equation says y is less than or equal to 7. Here my slope would be 0 and my y-intercept is 7. So I'm going to have a horizontal line up at 7. Okay, so all my points would go across here. Oops, that is at 5. So we are up at 7. Okay. We notice too that we have an equal to sign, so I'm going to have a solid line at 7. So I'll have a horizontal line that is solid at 7. I need to shade that. I want everything less than or equal to 7 according to my equation. So I'm going to shade everything underneath that graph. If they asked us for a solution, we would know our solution would have to be in that area that is shaded by both our red and our blue graphs. Looking at B then. So my first equation that I have up here, I have -1/3 x minus 6. We start at our y-intercept. Our y-intercept's -6. And I graph that slope of a -1/3. Using my rise over run, that means I'm going to go down 1 and right 3. Or I can go up 1 and left 3. When I connect those points, it has an equal to sign. So when I connect them, I know I need to connect them with a solid line. Next, we need to shade for that line. It wants the y values that are greater than or equal to it. So greater than or equal to tells me to shade above. So I'm going to shade above that line. If you'd rather use a test point, remember you can always pick a test point that's not on the line. So here I could pick a test point of 0, 0. And then you want to plug that test point into your equation. So I'd have 0 is greater than or equal to -1/3 times 0 minus 6. So 0 is greater than or equal to -6. Since that is true, we would want to shade where 0, 0, where our test point is. So again, we would shade the top side of that graph. The second equation, my y-intercept is going to be a +8. And my slope is 2/1. So I'll go up 2, right 1, or down 2, left 1. In that equation, we again have our equal to sign, so I'm going to connect this with another solid line. Oops. So we'll connect that with our solid line, and then we have to shade. It too says less than or equal to. Less than or equal to is going to be on the under part of that line. So I'm going to shade everything that's underneath that line. Okay. Make sure that we as teachers can tell where is shaded. Make sure that we know that this region, if you're just using a pencil, is shaded for both of your inequalities. See, we'll repeat this process. So again, I'm going to start with my y-intercept up at +3. I'm going to use my slope of 4/3, so up 4 over 3. Over 3 to the right if you're doing that. So then if you go down 4, you're going to have to go 3 to the left. This line will be a dashed line. So I'm going to do a dashed line through those points. Again, our dashed line is because we don't have the equal to symbol. I need to shade everything less than that line, so I'm going to shade everything underneath. My second equation then, I have a y-intercept of a positive 8, and then I have a slope of a negative 1/3. So we'll go down 1, right 3, down 1, right 3. I'm going to connect that then again with another dashed line because it is not equal to on there. So connect these points with that dashed line. It wants everything less than, so I'll shade everything underneath or everything less than that line. So our solution area again is everything that is shaded by both the blue and the red line. So everything in this area would be a solution. On D, I have a y-intercept in my first equation of -6. So I'll start by graphing -6. And my slope is a -3/5. So down 3, right 5, or up 3, left 5. We do have that equal to symbol here, so I am going to have to use a solid line to connect this. So we'll have that solid line through our 3 points. It asks us to shade everything greater than or equal to. So we shade everything that's bigger or greater than our line. Our last equation, y is less than -3. Y is less than -3. My y-intercept is -3. And I have that slope of 0, so I'm going to have that horizontal line. It needs to be a dashed line because it is not equal to. So I'll use a dashed line to connect those points. And then it wants everything less than that, so we'll shade everything underneath. In your summary, you might want to write to yourself things like remembering your dashed versus your solid. So if it's a less than or greater than symbol, remember we use that dashed line. If it's less than or equal to, or greater than and equal to, remember we want to use a solid line. You might want to put something in there too about your test points, or if you want to put something about how you know if something is a solution, how you have to make sure it is true in all of your equations. If you have questions, please make sure you come in and ask your teacher.